Hello everyone, my name is Tae-Sing Hui and I'm going to present the research with the title A Direct Proof of Entropy-Based Directed Random Walk. Before starting to present, I would like to introduce the agenda of my presentation. I will start with the introduction followed by literature review, methodology, result based on the theoretical proof of entropy-based directed random walk, and finally a conclusion. First, I will start with the introduction. So the basis of random walk theory is the process of starting from a single or group of nodes and visiting every node in a graph by taking a series of random walking steps. At each moving step, the nodes in the graph move to their random neighbor and a distribution value is calculated for every node in the graph. On the other hand, biological network can be represented as a graph, and random walk serve as a tool to study the interrelationship between nodes in the graph. And directed random walk is one of the popular graph theoretical algorithms used to solve many biological problems. So this paper is particularly aimed to apply Shannon entropy in directed random walk algorithm in order to calculate the distribution value along a biological pathway. And next, it is aimed to discover the interrelationship between entropy and connectivity of nodes via entropy-based directed random walk. And third is to show the role of entropy in revealing the biological insight for a gene and a pathway in the biological network. Next, I'll move on to the literature review of this research. So first, I will start with the random walk on graph. The procedure of random walk can be divided into 4 steps. Random walk process starts from a single or group of nodes, and then the nodes move on to the neighbors at certain probability, or meanwhile jump to other nodes at certain probability. And then step 2 is repeated until cover all the nodes in the graph. And then a vector is produced which stores the distribution value of every node in the graph. Next, I will explain the directed random walk algorithm. Directed random walk is aimed to mine the topological information in the directed network and infer a more robust pathway activity for cancer classification. Directed random walk starts the random walker on a source node S, and then the walker transitions from its current node to a randomly selected node based on the age weight at each time step, or return to a source node with a probability R. So this is the visual representation of the algorithm. And this shows the mathematical formula of directed random walk algorithm. R represents the result probability, M is the adjacency matrix, W represents the weight of initial node and the neighbor node. Next, I'll move on to the Shannon entropy theory. Entropy is a measure of predictability or randomness of data in information theory. When there is a high probability event, there is less information content and produce a low entropy value. In contrast, when there is a low probability event, there are more information content and produce a high entropy value. So next, I move on to the methodology of this research. Entropy-based directed random walk is proposed to discover the relationship between entropy and connectivity of nodes in directed graph via probability values calculated from Shannon entropy formula. Shannon entropy is proved to be useful in calculating the amount of information or uncertainty of a sequence in genomic data. Entropy of gene is used as the weight parameter to estimate the variability in expression for a single gene. So the basic calculations of the entropy-based directed random walk is shown. First, we start by averaging the expression value of the gene pair between two nearest neighbor genes, and then we calculate the probability of gene based on the average value, and then we further calculate the node entropy based on the probability calculated, and then we apply the calculated node entropy value in the directed random walk algorithm, and finally the distribution value for every node in the graph is produced from the entropy-based directed random walk algorithm. So this is the mathematical formula for the proposed entropy-based directed random walk. E represents the entropy age-weighted adjacency matrix, R remains the result probability, H is the entropy of the nodes and the initial node. Node entropy is calculated based on the entropy formula, and based on the entropy formula, the probability is calculated from the average expression value between the gene pair. So next, I move on to the theoretical proof of the research. So given an example of random walk for a gene from node 1 to each of the node until reaches node 6, So this example is taken from a paper. So the random walk of each gene from node 1 to node 6 is shown in a visual representation. So this table shows each of the node with the calculation of using the entropy-based directed random walk. Average gene weight is calculated and followed by the probability of gene weight and also the node entropy based on the probability value. So then after calculation of node entropy, the directed random walker is applied to calculate the final distribution value. So the entropy-based directed random walk is calculated for each of the node from node 1 to node 6, and then based on the result, the increase of entropy probability vector for random walking proved the feasibility of entropy-based directed random walk in controlling the randomness of search direction based on the biological rules exhibit in Shannon entropy of information theory. The increases in entropy can be used to identify gene signaling pathway, novel gene modules within the signaling pathway as shown in many papers. So next, to prove the interrelationship between the entropy and connectivity of nodes via the entropy-based directed random walk, we compute the entropy value between the first node and the other nodes. And the path is shown as follows. So this is the calculation table based on the theory. So we get the age weight for each of the gene between the node 1 and all the other nodes, and then we calculate the probability value and also the node entropy value. So this shows the calculation for each of the node 1 to all the other nodes using the entropy-based directed random walk. And based on the result, the high entropy value vector indicates the gene contains the larger information density and shows a significant connectivity underlying the probability distribution along the biological pathway. In contrast, the low entropy value vector reveals a low information content in corresponding connectivity of nodes and thus show an insignificant connectivity along the biological pathway. So in a conclusion, the entropy metric is useful to calculate the amount of information or uncertainty of a biological sequence. The proven results show that entropy vector not only applicable in calculating the distribution value along the biological pathway, it also discloses the essential biological information behind the concept of information theory. That's all for my presentation. Thank you.